Hello everyone, this is Ashwini Dashgupta here from Cheenta.com. This is a presentation from our mathematical Olympiad programs and the advanced mathematics programs for high school students. It's related to imagination and geometry. I stress this number of times in the class, and I will do that again here, that if you are trying tricky problems, if you're trying interesting problems, you have to sit down and imagine what's going on rather than thinking about which tool or which formula you will use at the very outset. Just take a feel of the problem. So here is a similar problem like that. I will talk about the crisscross, the crisscross philosophy. So what this is, the story begins with Descartes, really. And Descartes was a French mathematician. He was sitting in the trench during wartime, and he saw that there are spider webs, spider webs in the ceiling of the trench. Now, the spider web is letting the spiders to navigate through that web and eat insects that are sitting on that web. So the spider webs, if you have seen them, they sort of crisscross each other and they form sort of like a grid, right? Ever expanding grid. And using that crisscrossing network of spider webs, he discovered something that we know as the coordinate system, the Cartesian coordinate system. So in a coordinate system, what you essentially have is a set of grid lines, vertical and horizontal grid lines, each of which are perpendicular to each other. And why they're useful? Because if you are at a point, let's call the origin, then you can precisely tell where your friend is. So you can say something like this, that go 2 units to the east and then 2 units to the north, and you will find your friend. So you can give precise positions of your friend if you have the grid lines drawn in the map. That's one of the most important aspects of this crisscross philosophy. You want orthogonal lines. Orthogonal means perpendicular lines to each other. Actually, orthogonal has a deeper meaning, but for the moment, think of it like that: perpendicular lines which are crisscrossing the plane so that you can precisely tell locations. So today we are going to talk about a different way to construct this crisscross. A different way to construct this crisscross, and it's equally interesting and it's equally intriguing. So let me pull this up a little bit and draw a circle. You have to use your imagination a lot. So you draw a circle and then you pick a point on the circle. Let's call this point P. Okay. So what you do is you think of this, there is an infinite string attached to this circle, and you were sort of unwinding it, you were pulling it out. So at every stage, the string is like this. So these are like tangents to the circle, and whatever the length of this particular arc is, the length of this little string is also the same because you're unwinding it, right? So when you come to this position, it's like this. So the length of the tangents also keep on increasing because you are unwinding more and more and more. And what you get, looking at the tip of these unwinding string, what you get is the involute of a circle. You can imagine it will be like a spiral like this. It's called the involute of this particular circle. So it will continuously spiral out. It will continuously spiral out and fill up the entire plane except for the stuff in the middle. This region does not contain the involute. But apart from that, it will continuously sort of spiral out and spread over the entire plane. Now, let's draw this tangent line a little bit more carefully. Let's increase this length from here to here. So actually, I'll extend it infinitely, all of the tangent lines. Like this. So there are infinitely many tangent lines emanating from the circle, the points on the circle. The first question is this: what is the length of this gap? What is the length of this gap? Well, let's look at it. So if you, when you are here, this much length of tangent, and I can sort of show it closer, up close, is equal to this much length of the arc, because that's what you have unwinded. Now when you come back here, you have actually traveled the circumference one time and then you are back here. So you can now tell what is the length of this piece, right? Because that should be exactly, okay, let me tell you that it should be exactly equal to the length of the circumference, because that is the extra amount of string that you have unwinded. So we know how much the gaps measure. Now comes the fun part. What is the angle between this involute and the tangent line? So I have drawn the the green tangent line here, and the red involute. What is the angle between the tangent line and the involute at their points of intersection? Well, that's really easy if you think about it, and I'll let you think about it. But first, I'll tell you how to think about angles between curves and lines. So it's very simple. What you do is you just draw a tangent here and you measure the angle between these two lines. So if you want an angle between a segment and a curve, or maybe two crisscrossing curves, you can also have two crisscrossing curves, just draw tangents at their points of intersection and then measure the angle in the regular way. Okay, now coming back to this, can you tell me, this is a challenge problem in the comment section, can you tell me what is the angle between the tangent lines and the involutes, and with a reason? Give me a reason why you think your answer is right. This is presented from the Mathematical Olympiad programs at Cheenta. This is the curiosity part of the program. Remember, just learning some formulas wouldn't help. You have to learn to think and imagine and open your minds. And that's really what we are trying to do here together. If you have more beautiful ideas from mathematics, please do share that in the comment section. I will see you in the next one. And until that time, think about this problem and let me know what you have for the answer. Okay? Thank you all. Stay happy.